Most companies approach warehouse racking like they're buying basic steel shelving at a hardware store. That is a massive financial mistake. When you choose the wrong setup, the damage doesn't show up on the initial invoice. It bleeds your margins over years through excessive forklift travel, goods expiring in dead zones, and agonizingly slow picking times. This scorecard shows the priority shift. Effective layout design relies on two internal variables, SKU count and volume per SKU. There is no universally best racking system in existence. There is only the exact mathematical derivation of your specific inventory. Because a warehouse is a physical constraint you will live with for years, getting the initial math wrong will silently eat into your daily profit margins for a decade. This diagram illustrates the first essential variable, SKU count, representing the variety of items you carry. Higher variety strictly demands accessibility. The second variable is volume per SKU, the quantity of identical pallets for each item. High volume dictates a need for spatial density. Here is the central tug-of-war of logistics. Accessibility and density are naturally opposing forces in physics. You usually can't increase one without sacrificing the other. The golden rule of storage design is simple. High SKU profiles demand shallow racks so you can rapidly access diverse goods. High volume profiles demand deep racks to maximize your cubic space. Failing to balance these two exact variables forces a business into a corner. You will either waste expensive real estate or you will hopelessly cripple your operational speed. This quadrant chart maps these data points to categorize any business. The y-axis measures SKU count. The x-axis measures volume per SKU. Let's look at quadrant 4, the startup. These operations carry low SKU count and low volume. For early-stage segments, low capital expenditure matters more than maximizing vertical space. Floor storage works perfectly. Now shift to quadrant 1, e-commerce. They manage massive SKU variety, but low volumes, requiring selective racking or very narrow aisle setups. This shallow setup guarantees 100% accessibility. Order pickers can instantly find any of thousands of unique items without needing to move other pallets out of the way. For e-commerce, sacrificing overall building density to create massive forklift aisles is simply a mandatory tax required to achieve high-speed fulfillment. But what if your business deals in massive bulk rather than consumer variety? That brings us to quadrant 2, the B2B wholesale or distributor. You have a low SKU count, but extremely high volume per item, requiring maximum density solutions like drive-in or pallet flow systems. These deep lane systems intentionally eliminate picking aisles. Instead, they pack identical products tightly together to minimize the physical footprint. The severe operational trade-off here is restricted accessibility. If a picker suddenly needs a specific pallet buried at the back of a deep lane, it creates immediate logistical bottlenecks. Deep storage is highly profitable for optimizing real estate, but it is only viable if the business model can actually survive slow, sequential access to its goods. So what happens when a massive omni-channel hub demands extreme product variety and massive volume at the exact same time? Welcome to Quadrant 3. This is the domain of the enterprise, requiring both high SKU capacity and high volume depth. The only physical way to break the natural trade-off between access and density is through automated storage and retrieval systems, or ASRS. This technology delivers extreme density, rapid picking speed, and perfect accuracy, all at the exact same time. Cautionary. However, we need a reality check. While this technology is heavily promoted, it is not a magic bullet. ASRS comes with severe friction points. It requires rigid, multi-million-dollar capital investment, long installation downtimes, and a permanent reliance on specialized maintenance engineers to keep it running. Enterprise warehouse automation isn't about buying the best tech on the market. It's a calculated gamble that your long-term labor savings will eventually outpace that initial capital shock. We also have to remember that businesses are not static entities. Supply chains evolve, product lines expand, and companies pivot over time. This flowchart shows the danger of building permanent warehouse infrastructure based strictly on today's data snapshot. If you don't project growth, a highly optimized system today can become a literal roadblock tomorrow. Imagine a traditional wholesale business with a low SKU count suddenly pivoting to direct-to-consumer e-commerce. which requires a massive increase in SKUs. If that business is heavily invested in rigid, deep lane infrastructure, they will face severe operational paralysis during that pivot. Over-investing in rigid systems too early in your life cycle is one of the primary killers of expanding small to medium enterprises. Strategic warehouse design must account for both the mathematical reality of your inventory today and the business model elasticity you will need for tomorrow. Warehouse design is the physical manifestation of your inventory policy. Your immediate next step is not to call a racking vendor and ask for a generic quote. Instead, pull your raw inventory logs, calculate your precise SKU count and your exact volume averages first. Then map those specific data points directly onto the framework we just discussed. If you map your variables correctly, the math will automatically dictate the exact hardware requirements you need to succeed. High-performance logistics comes from the precise alignment between raw business data and physical infrastructure.